how does a hash map actually work? When you call put or get, a lot happens under the hood: an array of buckets, a hash function, nodes that link into lists and even trees, and automatic resizing. Let's open it up completely. Insert, collision, search, treeify, delete, and resize one step at a time. At its core, a hash map is just an array. Each slot in that array is called a bucket. When you create one, the default capacity is 16 buckets and the load factor is 0.75. We'll see what that means shortly. Every entry you store is wrapped in a node object. A node holds four things: the key's hash, the key itself, the value, and a next pointer to the following node in the same bucket. Remember those four fields: hash, key, value, next. Let's put Alice with value 25. First, Java calls Alice's hash code. It spreads the bits, exclusive or with hash shifted right 16, then computes the index as hash and capacity -1. That bitwise AND is just a fast modulo by 16. Here it gives bucket 3. So the node for Alice is placed into bucket 3, hash, key Alice, value 25, and next pointing to null. Now add a few more. Bob hashes to bucket 7, Dave to 11, Gus to 15. Each key lands in its own bucket, so each is a single node list. But watch this. Kara also hashes to bucket 3, the same slot as Alice. That's a collision. HashMap doesn't overwrite Alice. Instead, it appends Kara's node to the chain. Bucket 3 now holds Alice, then Kara. A couple more collisions. Eve joins bucket 7, and Finn joins bucket 3. So a single bucket holds a linked list of nodes. Bucket 3 is now Alice, then Kara, then Finn. This is called separate chaining. It's important to see that sharing a bucket does not mean the keys are equal. Alice, Kara, and Finn just happen to land on the same index. They're different keys, so all three are kept. Only an equal key would overwrite its own value. Now let's retrieve. Get of Kara. Step 1, hash Kara to find the bucket. That's bucket 3 in constant time. Hashcode tells us which bucket to look in. Step 2, walk the chain and call equals on each node. Alice.equals Kara? No. Kara.equals Kara? Yes. Equals is what distinguishes keys that share a bucket. Found it? Return 25, return 28. So get is 2 steps. Hashcode picks the bucket, equals picks the exact key. This is exactly why when you use a custom object as a key, you must override both hashcode and equals consistently. Here's the danger. If your hashcode is weak and returns the same value for many keys, they all pile into one bucket, forming a long chain. Searching that chain is linear. Order n, no better than a plain list. Java 8 fixed this. When a single bucket grows to 8 nodes, and the table is at least 64 big, that linked list is converted into a balanced red-black tree. Now even a worst-case bucket is searched in order log n. If it later shrinks below 6 nodes, it turns back into a list. Deleting works the same way at the start. Remove of Kara. Hash to bucket 3, then walk the chain with equals to find Kara's node. Then the node is unlinked. Alice's next pointer is rewired to point straight at Finn, skipping Kara. Kara is removed, and bucket 3 becomes Alice, then Finn. Now, resizing. The load factor is 0.75, and capacity is 16. So the threshold is 16 times 0.75, which is 12. The moment you insert the 13th entry, the map crosses that threshold and triggers a resize. On resize, the capacity doubles, from 16 to 32, and every single entry is rehashed to its new index using hash and 31. Resizing is order and work, but it happens rarely, so on average it costs almost nothing, and it keeps the chains short. Let's total it up. Put, get, and remove are all order 1 on average. The worst case is order log n for a treeified bucket in Java 8, or order n before that with a long list. A good hash code keeps you firmly in constant time. The whole picture, a hash map, is an array of buckets. A key is hashed to an index, entries chain as a linked list, and treeify when a bucket gets long. Get uses hash code to find the bucket and equals to find the key, and the table resizes to stay fast. Master these 6 ideas and HashMap holds no secrets. Interview round. How does put work internally? Hash the key, compute index as hash and n -1, and place a node in that bucket. A collision appends to the chain, which treeifies at 8. An equal key overwrites. Crossing the load factor triggers a resize. How does get use hashcode and equals? Hashcode picks the bucket in constant time, then it walks the chain or tree and uses equals to match the exact key. override both consistently or lookups break. What is treeification? When a bucket hits 8 nodes and the table is at least 64, the linked list becomes a red-black tree, cutting worst-case lookup from order n to order log n. It reverts to a list below 6 nodes. Default capacity and load factor, 16 and 0.75. When entries exceed capacity times 0.75, that's 12, the capacity doubles to 32 and everything is rehashed. And the time complexity? Order 1 on average for put, get, and remove, order log n worst case with treeify, or order n before Java 8. A good hash code is what keeps it constant. Now it's your turn. Take the topic test and lock it in. 10 multiple choice plus 10 short answers graded by AI. The link is in the description below. And here's something special. Top the leaderboard on 5 topics in a row, and you'll get a surprise gift from me, plus a personal one-on-one connect.